Thank you everyone for joining and spending. All right, can you hear me? Just testing. Can you guys hear me out there? All right, hopefully everyone can hear me out there. Just waiting for some confirmation, and we'll get started. All right, why don't we kick this off? First, I want to welcome everybody to this walkthrough of how to use Avesha's community version of our kubeslice technology. Today we're going to walk through the getting started process in basically a 2-cluster installation of kubeslice and deploy an application on it. And we'll be walking through the online instructions to do that. First, though, let me just set some context so everyone's sort of aware of what we're talking about. This is the architecture for kubeslice. We have a kubeslice controller that oversees the connectivity between a collection of clusters. For the community edition, what we've done is we've installed an instance of the controller in the cloud, and we made it available for anyone to log into and use. So you can take the Avesha artifacts and install them on your own clusters and connect them together. So to get started, the way you would get going here, if you go to avesha.io, it's where everything begins. We have the big getting started button right on top. And if you take that, you'll get kubeslice Community Edition and the register button. So you click register, and here it just asks for some information. Company name, your name, and an email address, and just accept the terms and conditions. And once you click register, you will get an email from Avesha with a collection of information that you're going to need later in this installation tutorial. The key points are this API key and the token, but maybe even more key than that is the link to the documentation. So if we follow that, you land here in the kubeslice installation guide. We've got some overview stuff. We'll jump into getting started. And first off, there's this prerequisite section, which I'm really just going to kind of skim over, but I want to make you all aware of what's here. We have a listing of a number of some required tools like kubectl, as well as some convenient tools like kubecontext, which is very handy for switching between clusters. There's details on requirements for node sizing, where you're going to put the Avesha node, as well as details on how you'll have to set up your cloud environment. The base requirement here is you have clusters running in multiple different places, and they need to be able to talk to the controller and talk to each other. And so if you're launching it in one of the public clouds, you may need to expose like a VPN port or two in order to get the connectivity to establish. And we also have some details on how you can configure RBAC requirements so that you can install the kubeslice artifacts without being an admin. Now, what I have set up here so far, I've already got that together, so I just want to make sure you all know that there's some information out there on how to do the installation if you don't have admin privilege. So for this demo, what I've already done is I've decided to use Google Cloud. So we can quickly go there and see. I've set up two clusters, one in Northern Europe and one in Central US. And I've already configured nodes and gateway pools and configured the firewall information and everything. So the clusters are basically ready to go. Inside of I have a Linux environment here. I've installed the various tools. I've made sure that I can get to the Avesha Helm repo and otherwise have everything in place so that I can begin my my installation of kubeslice. So with that, let's just jump ahead. And get on to how to install kubeslice. So the first step is you have to register each cluster. To do that, you create a YAML file that's going to describe the details of your cluster. And this is where you need those keys that came in the email you had before. This API key and the token key are fields that you're going to have to fill into your YAML file that you create to register your cluster. And you'll see all of the documentation here has these copy buttons, so you can easily copy and paste the information we have here in the instruction set. So what I've done here, I have created these YAML files by copying the contents from the website. So I did a copy here. And then I went and I filled in the API key and the refresh token. With that information that came from that email. What that does is it tells the back end which set of clusters to associate with each other, so that your set of clusters is staying uniquely yours, but you're able to join as many clusters into that set as you want by sharing those keys. And I specified where it is, EU North, and give it a site name. So, what we describe here, we have a couple examples of what the YAML would look like for some of the different public clouds. There's some slight differences. But then to actually install the Avesha mesh, you can do a Helm install, and again, just copy the instructions from here. First, let's see where we are. So we have 2 clusters, and right now we're in EU North. So we're going to do Helm install Avesha mesh, passing in the EU North YAML file. We'll get that going. And now that's installed. And so we'll go to the other cluster, US Central, and do the same thing, except this time we're going to install the US Central version. And one thing I should point out here, we compare the 2 YAML files. We have US Central on the left and EU North on the right. Again, they look very similar. They have, by sharing that same API key and refresh token, that's what says that these 2 are allowed to connect to each other. They're only differing in the information at the bottom. So now that we've applied that, we can make sure that everything got installed correctly. So let's just double check and check the pods. And everything's up and running fine. So that's a good sign. And we'll just check the other cluster and do the same thing. Make sure that's all good. So we're all smooth there. So next up, we're going to install a slice onto those 2 clusters. And we have the same dynamic here. In the instructions, you see a bunch of description of the various fields you'll have to fill in to describe the slice. And down below, we have a template of a slice. And you would copy that and paste it in your favorite editor and fill in the fields. So I can show you mine. So I left the comments over here on the right for the fields that had to be filled in. We're going to call this slice Demo 1, display name Demo 1. Pick a subnet. Now this is when we connect clusters together on a slice. What we do is we create an overlay network that's within the scope of that slice. And we have to give that network an address. So here I've chosen to give it 192.168.00/16. You can choose whatever you want. And you can actually use the same subnet with different slices. So if you wanted to standardize on something for your topology, you could. You can specify QoS profile, namespace isolation, decide which one to do with Istio. And once you have all that together, then you're going to apply it. So let's take a look at that. So we will copy this command Going to do the Helm install. And like I said, our slice is called demo1. And we're going to use our slice demo1 YAML file to install it. So now that's installed, and we need to do the same thing in the other cluster. So now I've gone back to US Central, and I'm going to install the same slice YAML here. You can install the same slice YAML in each cluster. All right, so that applied. Let's quickly just go back and look at what we've done so far. So we've provisioned our clusters. We installed, we specified gateway nodes in each of those clusters. We've installed the Avesha kube slice artifacts in a namespace on each of these clusters, and we've defined a slice. You can think of it like this green slice here, demo1, that spans the two clusters. So we've connected the US Central cluster with the EU West cluster. Now we can confirm the functionality, make sure everything is working on the slice. Again, we have validation things here. So we'll copy this get slice command. Good. And let's just check the other cluster. But even better than that, we can check the gateway installation and make sure that really all the end-to-end communication is ready to take place. So let's take a look at the other one. So right now, what we have is the two clusters, they have their subnets provisioned. So this cluster knows that it's going to be 192.168.1/24. The other one's chosen to be 192.168.2/24. But they haven't finished talking to each other yet. So let's check again. There. And now, so this cluster, we're in US Central. So US Central now knows that its peer cluster has this remote subnet and is reachable. And if we switch over to the EU side and do the same thing, it now knows what its peer is too. So he has his local address, and he knows the subnet of his remote cluster as well. And if you had multiple clusters, you would see them all in here. So now we have our clusters together. We have the slice defined. Everything is up. Next up is to actually put an application on the slice. So this onboarding application page is a little bit general because we're trying to describe how you would bring an arbitrary application onto a slice. So there's a couple general things you need to do. Typically, you have an application that's deployed using a YAML file, and so what you would need to do is go into that YAML and annotate it with something like what you see here. and you just say, for this application, I'm going to put it on the slice. Now, depending on your application, a given service may want to advertise that it is offering a service that should be reachable from a different cluster. And to do that, you need to do a service export. So again, we describe the kinds of things you have to configure about the service export, what its name is, what slice it's on, what ports it's on, these kind of things. And we have an example YAML here for how you would do that. So these are the things you need to do for a given application in order to put it on a slice and make it reachable by other things in other clusters that are on the same slice. Now, again, this is sort of a general page. If we go ahead, we have a couple tutorials that talk about onboarding specific applications. Here we go. So I'm going to bring on the iPerf application. iPerf is it's a fairly simple application to test connectivity from one place to another. So it's an easy example to show here, but the same logic extends to any other application that you'd want to onboard onto a slice. iPerf has two pieces to it. One piece called iPerf Sleep, which is essentially a client, and the other one is an iPerf server. So the client talks to the server. So in this case, iPerf is publicly available. It's on the internet. You can download it. We have packaged it on our, it's available in the Avesha Helm repo, again, just as a tutorial. And you can set it up using the example YAML file that we've provided here. And so if we go back and look again at what that YAML looks like, oops, let's start with iPerf client. The key thing here is just adding in the annotation, saying I want to put this application on a slice. Other than that, we didn't have to change anything about this YAML file. So, if we want to deploy this now, we're first going to create a namespace for iPerf. Actually, you know what? Let me just flip sides here. Let me put this over in US Central. So we create the namespace. Now we're going to apply the YAML file to turn on this application. Okay, so we've brought the iPerf client app onto the slice. Let's just make sure that it's really there. Take a quick look at it. So kubectl describe slice is going to describe this demo 1 slice. And what you see here, again, we have the subnet for the slice. We have the iPerf Sleep client application. And it has an address that's, one of which is on the CNI network in the Google Cloud. And the other one is its address on the overlay for the slice. So it's there. That's good. And now let's do the server side. So let's switch contexts again. So now we're back in EU North. And we're going to do the server. Same deal, the server has a YAML file that you can copy. The example we have here has both the definition for the server itself, but also the service export. And so those are the two things you would need to annotate when you bring it into your slice. Let's take a quick look at what that YAML looks like. So again, the only things we changed here, we added an annotation to say I want this on the demo 1 slice. And we created this service export to say that we want to make the service iPerf server visible on the demo 1 slice. So let's install it. First, we're going to create the namespace again. And then we'll apply the YAML file for it. All right, so that's installed. And again, we can check this by describing the slice and seeing what it has to say about the server. So just like on the client side, we have the servers in place. It has a CNI address, but it has an address on the overlay network as well. And as you can see, this is a 1.5, and the other one happens to be 2.5. So now let's make sure they can actually talk, just to prove that the connectivity between the slices is actually completely working. So let's go back over to where the client is. And we're going to go, if we go inside the client, well, you know what, before that, let's just take a look at the service announcement. So we can show that the service has been imported. By going over to this cluster. And you can see iPerf server is now visible in the US Central cluster. Again, it's defined over in EU North, but it's visible in US Central, and it's reachable at that IP address. So we can finally test out the connectivity. We just go inside the iPerf client here. One thing I like to do is trace route. So we'll trace route to this address. And what this is showing you is, well, the first hop is the local iPerf client. The next hop is actually the overlay router inside this cluster. The hop after that is the tunnel that's going between clusters, and it's actually set up not to respond to traceroute. That's why you get the dots. Then on the far side, over in the EU, and you can tell, you notice the latency change going around the world there. You have the gateway on the EU side, and finally the iPerf server that's at that address. And we can trigger just normal iPerf traffic, run a simple test. And there we go. So everything's talking between US Central and EU North. And there you have it. You have an application on a slice across multiple clusters. Now, I'm sure if you've tried this out, you may onboard your apps, you may play around with it, but at some point you may be done. And we just want to make sure you know that you can gracefully uninstall all this too. So we do have instructions on how to uninstall kubeslice. And you basically unwind everything. You delete the service export, and then the apps, and then slice, and then the mesh. So we can just do that here. Get out of iPerf. There, that's better. And you know what? Let's start with the server side. So, I'm going to delete. And now the server's gone. We'll remove the slice. And then remove the kubeslice mesh itself. And we'll change clusters just to clean up the other side too. Remove the client. Remove the slice. Remove the mesh, and finally clear out your leftover namespaces. And now we're just back to where we started. We have our clusters clean and ready for another install of whatever new app we want to try. So with that, I will ask if there's any questions. See if there are any questions. All right, so if there's no questions, then we'll wrap it up. Thank you very much for your time, and be sure to give Kube Slice a try. Thanks.